what we're going to be going over here is the units parameter of a production function, and our production function is really going to be similar to the Cobb-Douglas production function. Okay, so this is our production function here. We're going to have some output Q here, and really that represents our total production, or the value produced. And in this case, it will be some profit here. And that's equal to Y here. And really, Y is the total factor of productivity. Then this is really going to be some revenue per unit of product we're selling here. And you take that times some, and we'll be looking at two inputs here, material and labor here. So our material and labor here, those are input values here in units that we're looking at. And each of those here are raised to some exponential amounts here. So in this case, that A and B here, that would be the share of the productivity of the output here, that material and labor are contributing to the output Q here, or the profit that we'd be looking at. Okay, so and what we'd be looking at here in terms of our production function, we'd have some profit is going to equal some revenue minus our cost. Okay, so this is what we'll just start with our production function here. Now, we talked about the cost here. Well, I'm going to leave those costs out here on a per unit basis. So we'd had some material cost here on a per unit basis and some labor cost here on a per unit basis. But really what we're going to just function on is this revenue portion here of our production function. Okay, so let's look at it here. So this Y here that we looked up out above here, this units parameter here, we'll just set it here at $1,400. That's the revenue per unit here of a product we're selling here. Okay, so what we're going to be concentrating on is this units parameter. So we've got $1,400 per unit here, this product we're selling, and the units parameter, that really represents our output here in terms of units here. So we have dollars we're generating here, so we're going to have dollars in profit that we're generating over here. Okay, so then remember we had that material and that labor here on a unit basis here that we'd be looking at. So this is what we're going to use for example here. This point for material is going to be raised to the exponential amount here of 0.5035, and really what that's telling us is that represents the share of our output based on the input that we're using here for material. So material really represents approximately 50.3% of the profit or the output here. And then you take that material times your labor, whatever units of labor you're looking at here, and we're going to raise it to 0.325 here. And really what we're saying here again, labor represents about 32.1% of the profit here based on whatever input we're using here, or units we're using for labor. Okay, so then what we're going to be doing is looking at this units parameter here. It really becomes a scalar amount. So again, just what we're going to be going through here is looking at the maximization here, maximizing our profit. We would have come up with looking at just our equal product or isoquant lines here. We would have come up against some constraints. I'm not going to show them in this example, but we had some constraints here based on material and labor here, and based on our feasible area here, we come up with some maximum profit here. And really what we're looking at, this units parameter, that's going to be the real output per unit of input here, material and labor here. That's what we'll be looking at. And we're going to be looking at the effect of changing our units here. Okay, so we'll go on here. All right, so now this is what we're really going to be dealing with, the total factor of productivity. So this was our production function here, and our output here, and we'll just say this $1,400 revenue per unit, we'll just say we'll change it to some amount A here. Okay, so, and that's times our material and labor here. So let's just rearrange this equation here. So rewriting our production function, we're going to come up with the measure of our total factor of productivity. So what we do is just divide both sides here by your material and labor here, and that's going to give us your profit here. Q here is going to be divided by our material and labor here, and that's going to equal A here, our selling price or our output here. Okay, so the selling price, or in this case it was selling price here, but that I'm looking at here, this A here, now that really represents the real output per unit of input here. So our denominator here for material and labor here is really a geometric weighted average here of the inputs used here to produce the real output here, which would be selling price per unit or something that we'd be looking at here. Okay, so that's what we've done here by rearranging that equation. All right, so let's go down here and we'll just look at two cases here with that equation that we looked at here that we rearranged it. So we're looking at the first case here where we're going to have, and what I've done here is I've just left in some what for this selling price that we'll be looking at here. Let's just say that was at $1,400 a month. I've got it here in the denominator here times that production function or our rearranged equation here, Q divided by M and L here. So let's just look at what we're talking about. Our units of input here for our M and L here, and our profit here would be Q here. And let's just say, for example, we had a profit here of $82,533, and our selling price here would have been $1,400, unit price here $1,400, which is shown here. And then we have, based on that profit here, we had material at 70 units and labor here at 78 units. So what we're doing here is just solving for A here, and that's really measuring our productivity here. So based on our inputs here, say that selling price here of $1,400 and our Q here of $82,533 profit, it would come out here, and we would have, and our material and labor inputs, A would have come up to 1.711 here. And really what that's saying is we could have raised our profit, our selling price here, our revenue per unit, from $1,400 up to $2,400 here. I mean, you know, that's what it's really telling us, is we're really more productive here than based on that $1,400 revenue here. We're more productive based on our profit that we've generated here. Not to say that you're going to necessarily be able to increase your revenue up to $2,400, but if we had the profit with the material and labor inputs that I'm showing here, we would have had our measure of productivity would have went up to 1.7 times our $1,400, up to approximately $2,400. So you can see what's going on here. If you could put some targets, some profit based on your material and your labor inputs here, and also your revenue or unit price here, you can come up with some measure of productivity, either above or below the unit price you're looking at. Okay, so really what you want to do is you're going to be changing your variables here between your material, labor, and your profit here, and you can determine some A ratio here based on that revenue per unit here, the selling price per unit. It's either going to go up or down here, but it can become a useful tool. Okay, so that's really the first situation here. And then if we move down here, let's just say we'll take this fractional amount here, 1,400, or our selling price divided into the unit of 1 here times our profit function here. Let's just take that out of here and just leave it out. So if this is the case here where we have same values here. We had, say, a profit here of $82,533 divided by some material and labor inputs here of 70 and 78. We would have generated our selling price, or our revenue per unit here, would be $2,396, or about $2,400. So what we're really looking at, this A here, based on rearranging our equation here, we're really looking at the real output per unit of input for material and labor. So that really gives us our real output on a per unit basis here. So again, change your variables around here to determine your output. So again, this can be good because if you had some targeted profit here based on some material and labor inputs, you could determine your sales price here and revenue on a per unit basis here. So that's what we'd be looking at here. So we'll continue on here and look at some graphing or plotting here of our real output here on a per unit basis. Now we'll look at our production function here plotted out in 3D here, or showing our profit here based on our inputs for our material, our labor here, and then our sales price or our revenue per unit here. We'll start out at $1,400 per unit, and based on that we're going to generate some profit here, profit Q. So in our 3D plot here, I've got Q here, our profit increasing on our vertical axis, moving up, and then for our inputs here, I would have had some inputs based on our linear programming here for our material. moving from 0 to 150 units in this direction, and then labor from 0 to 150 units in this direction. So based on those inputs, and we would also had some constraints in there for our material and labor constraints. But based on that, this is our production function here based on a $1,400 revenue per unit. So you can see what's going on here in this curvature here. So we start out with some higher revenues, or generating some high revenues here at a greater rate here when we start out here. If you look at it M, you'd have to look at it from the other angle here, but just in terms of L here, you can see that your revenue is generating at a faster rate here with the lower inputs here in L, or lesser degree of input here in L, or lesser quantity or units here in L, and that's because of the marginal product of labor and marginal product of material. But as you increase the units or the input here, you increase your profit, but at a slower rate. But what we're really looking at in this problem here is that A, or our sales price, or that scalar amount here, A here, that's using here on a revenue per unit or sales price per unit to generate our profit. So again, you can see what's going on here. Our maximum output with our constraints is going to be at some input here, 70 units of material and 78 units of labor, and we would have generated $48,144 here of profit. That's not including our material and labor here that I didn't include in the equation here for the cost here. I'm just looking at it in terms of this basic production function here. Okay, just to understand that. So here's our max profit right here, or maximum output as we should call it here, based on those constraints. Okay, so that's with just looking at our sales price here, or our revenue per unit at $1,400. Okay, so let's move over here now. Now, what we're going to do in this case, we're going to increase our revenue here from $1,400 per unit up to $2,400 per unit. So I'm taking our A quantity here and putting it in our output, in our production function here, and you can see obviously it's going to generate a greater profit here. So what we're doing here, that goldish one here, now that was what we first looked at, where our A, our selling price or our revenue per unit was $1,400. Now let's just move it up to $2,400. So you see what's happening to our production function here, or our profit function here. It's increasing here. But what you're going to notice here is that the quantity for input for L and M doesn't change. It's going to stay the same here, for 70 units for M, 78 units for L. And that's based on our linear programming, our maximum profit based on those constraints. But what did change here, by increasing our input here in our revenue, or our selling price here, from $1,400 to $2,400, we increased our profit here. Again, at a certain rate here. You can see a decreasing rate, but nonetheless, we've come up with a greater profit here based on increasing our revenue, which makes sense. But what you're going to find out is that this profit here, these points that we're looking at, that are maximum points here, that are the maximum where we're maximizing our output here, they're going to be at the same point. And that we noticed here based on our first plot here, we're sitting at 70 units of material and 78 units here of labor here. Okay, so that's with looking at our case here, we're gone from 1,400 to 24. Now remember, based on that here, all our inputs are at a greater productivity, or have greater productivity, just simply by increasing our revenue, if in fact we can increase our revenue at that point. This is only to demonstrate the point here where our output based on our labor and material inputs are going to stay constant here. Only thing that's changing here is the revenue, or increasing our A amount, or our scalar amount here in our production function here. Okay, so that's with two different inputs. All inputs have greater productivity. Now just moving over here, here's the case again where our first input here is showing it here again, where we have our input here for our revenue at 1,400, then we moved it up to 2,400, showing here. That's the 1,400 was the goldish one here. This grayish line here, or grayish surface here, is our profit here, function based on 2,400, and now we kick it up to 3,400 here, increasing our revenue or sales price here on a per unit basis. We move from 24 to 3,400. Again, you can see what's going on here with your production function. Everything is increasing here. All inputs have greater productivity simply by looking at that revenue here, where we increased from $1,400 per unit shown here, $2,400 per unit shown here, $3,400 per unit shown here. So what, again, maximum output is going to is increasing, our profit is increasing here, but the quantity of our inputs for material and labor are staying constant. Okay, so that's just looking at three inputs here. Now you can put, again, you can put any scalar factor you want here into your equation here. If in fact you can actually sell at that price here is another question. But anyway, it's giving you a representation of what's going on. And the only thing that isn't changing are, you're going to have the greater profit, but there are all these, your actual maximum output based on your linear program here is the same. Okay, so if we go down here now, okay, we're looking at the same thing we did in that last 3D plot here. Again, Q here, our profit is increasing along our vertical axis here, and then our M here is increasing this way, L is increasing this way, and then we have this, our output here, or our production function here. Again, and all I've done here is I've just plotted out the maximum profit here, or based on that production function that we have here, and all I'm doing is showing this. The quantities of material and labor are not changing. The only thing that is changing is your profit here by changing your revenue per unit or the selling price per unit. That A quantity that we're looking at, again, here, this goldish one here was for our A revenue at $1,400 per unit, grayish one here, $2,400 per unit here, and lastly, this last, or this top service, or this production function here showing at $3,400 per unit. You see what's going on here. At $1,400 we were sitting at $4,800. Then at $2,400 we moved up, or $48,000, excuse me, and then we moved up from $2,400 per unit here in revenue, and that generated $82,533. And then looking at $3,400 here, that revenue per unit or sales price per unit move us up to $116,992. And all I did here is I just plotted it out. I just run a line up through here just to show that we have the same material and labor inputs here at that maximum production function or profit area here. The only thing that changes is our profit here based on our A or our revenue or our sales input here in our production function here. Okay, that's all I'm showing here. Okay, so that's the basic understanding here, is that all inputs become more productive, but the quantities here based on a quantity of material and labor, they really don't change in this case, where we maximized our profit based on our production function here with our linear program. The only thing that's changing here is our profit output, along with the corresponding increase here in sales price or revenue per unit. Okay, so we'll continue on. Now we'll make a comparison here, looking at equal product curves here, and we're looking at material and labor here, and then we have some constraints for the material and labor here, and then this green area was our feasible area, our feasible solutions for our linear programming. And then based on our constraints here and the production function that we have here, we come up with our maximum profit. It sits right up against one of our constraints here. But really what we want to look at is these equal product curves. So some combination of labor and material sitting on the curve you're sitting on is going to give you some equal profit, essentially. Okay, so the first one here I'm showing in blue here, the navy blue, is based on $1,400 selling price based on our production function here. So if we move over here, looking at the case where we changed our selling price from $1,400 to $2,400, I'm showing those equal product or ISO curve lines here shown in gold. Okay, so now let's just take and combine both of those. So going over here, all we did here is I've graphed them both here for labor and material inputs here, and taking the graphing the $1,400 revenue against the per unit versus the $2,400 revenue per unit or selling price. they just overlay each other, just to make, that's all I'm trying to show here. They just simply overlay each other. You're going to have the equal quantities here between material and labor, some combination. They're the same here, regardless of what you do here to change your revenue or your selling price or your scalar amount here in your production function. They just sit on top of each other. The gold was our 2400, and they're sitting right on top of our navy blue ones here at $1,400 a revenue or selling price per unit. And then if we go over here and just look at, remember we plotted that production function out here in 3D here based on, again, our production function here, where all our inputs, our productivity are increasing and are just moved from 1,400 selling price, 2,400, 3,400. You can see those. So that's all like making the comparison, just to understand here. Make the comparison here with your ISO curves or equal product curves. All you're doing is your Q change, or your profit is changing with an increase here in your selling price or revenue per unit here, but you're having the same same quantity or combination of material and labor here is going to give you your same maximum profit based on the constraints we have here. So just to make the understanding here, looking at our 3D profit function here based on our production function versus our ISO curves here, just to make that understanding. And then finally, if we go down here and let's just look at our, remember, rearrange that equation here, that production profit equation here, and we just isolated, or we brought our sales price or our revenue per unit over on this side of the equation, and we had our profit here divided by our inputs of M and L here. And then in this case, just looking at our productivity on a unit basis, I'm just showing here where we have our selling price here set at $1,400 or $1,400 per revenue. All I'm doing is showing it plotted out here in 3Ds, where I got that productivity factor here, showing as A here along our vertical axis, and then we have those inputs for our labor and material here increasing in these directions here. But all I'm saying, looking at, you can plot, it's just good to look at it in a 3D plot to understand again what's going on here. So you can see your productivity factor is decreasing here as you increase your inputs for labor and material, your productivity factor is going down. All right. And then if we move over here and just look at it where we change our selling, or our, say, our profit here, Q, our profit here, and we can manipulate our inputs again as far as our M and labor here. But if we change our, just looking at this A here as a productivity factor, again, just increasing our selling price here, and I'm just started at 1,400, and then we increased it on up here. And I'm just showing about 3 or 4 different levels here where I increased the selling price of the revenue on a per unit basis. So you can see you're having a greater productivity factor when you increase those revenues here on a per unit basis or your selling price, but they are again decreasing here when you increase your material and your labor inputs. And then finally, and that's looking at it just in unit amounts here, looking at that productivity factor here, or actually your revenue here per unit, or revenue per selling price per unit here. And then finally, if we just go over here and look at it, graphing it out here as a sales price per unit here, all I'm doing is we're changing our Q or our profit here based on our material and labor inputs here. So we're going to have, this is the case here where A here, this is the real output per unit of input of material and labor here. Again, just looking at the numbers here, you can graph it out looking at the sales price. Before we were just looking at some productivity increases on a unit basis here, but now we're looking at, you can look at the sales price here in real terms here. So this is really looking at it in these terms. When we rearrange that equation, we really are looking at the real output per unit of input here of material and labor. Again, as you increase your material and labor, your real output is decreasing here. But nonetheless, you can get some feel for what you're talking about here when you're talking about real output versus just profit alone here. Okay, so that'll summarize our discussion.